Hey everyone, welcome back. Today we are rolling up our sleeves and diving into the world of AI development. Get ready to code along with me as we build our very own AI art generator from scratch. We will be building a personalized artwork creator in which users can describe a scene for their artwork and choose a style like realistic, futuristic, abstract, fantasy, etc. for generating their artwork. Alright folks, it's time to get our hands dirty with some coding. In today's session, we are going to address the burning questions you have been asking about coding your own AI art generator. Whether you are a seasoned coder or a newbie, we have got you covered. So let's dive in. But before we jump into the code, let's address a common question. What tools and access do I need? The first tool we will be using is AWS Bedrock. In simple terms, AWS Bedrock is a suite of machine learning services offered by AWS designed to help developers easily build and deploy AI models. Make sure you have an AWS account that you can access and you are subscribed to the AWS Bedrock services. Also, ensure you have been provided the access to the model that you would be using by checking the model access section in Bedrock. Now to access Bedrock services programmatically, you will need to have an IAM user that can access Bedrock. This IAM policy is a sample that should be created to grant access to Bedrock APIs. Once you have this set up, generate the secrets access key and access key ID and have it handy to set up a development environment. The next tool we would be using is Boto3. To put it simply, Boto3 is the AWS SDK for Python, which allows Python developers to write softwares that make use of services like AWS S3, EC2, and in our particular case, the Bedrock services. The final tool we will be using is Streamlit. In simple terms, Streamlit is an open source Python library that makes it easy to create and share beautiful custom web apps for machine learning and data science. We will be using Python as our coding language. Now that we are clear about the tools and accesses required, the next major question you might be having is, how do I set up my environment for this development? Let's understand what we need. I'll be using my Cloud9 environment for development. You're free to use any IDE of your choice. As a first step, type in the command AWS configure in your terminal. If you receive an error message pointing out that AWS CLI is not installed, go to AWS documentation, get the latest AWS CLI version, and install it on your system. After which, if you type AWS configure, you will be asked for the secret access key and access key ID. Provide the one you would have generated from your IAM user. Now, if Python is already installed in your system, you can install Boto3 and Streamlit using pip install Boto3, pip install Streamlit. Now that we have the development environment set up, let's address a concern that you might be having. Let's say you're new to coding or have limited coding experience. Can you still follow along? The answer is yes. As I code, I will break down what each piece of code is doing. This way, you can easily follow along and use this code for your own learning and projects. Let's start with importing the libraries. This section imports essential Python libraries that the application relies on. Import OS, not explicitly used in the provided code snippet, but typically included for interacting with the operating system, such as reading environment variables or file paths. Boto3, the AWS Software Development Kit for Python, which allows Python developers to access AWS services like Amazon S3, EC2, or in our particular case, the Bedrock service. JSON, a library for encoding and decoding JSON data. In this application, it's used to pass the response from AWS Bedrock and to format the request sent to it. Base64, a method for encoding binary data into ASCII characters. Here, it's used to decode the image data returned by the AI model, which is typically encoded in base64 to facilitate transmission over networks. Bytes.io, a class from the I/O module that creates an in-memory binary string. This is used to handle the decoded image data, allowing it to be processed and displayed by the application as if it were a file. Streamlit, a library for creating web apps quickly. It's used here to build the user interface for the AI-powered image generation tool, handling user inputs and displaying outputs. Now, let's initialize the AWS Bedrock client. AWS Client Setup initializes a client to interact with the AWS Bedrock service using Boto 3. The Bedrock Runtime Client is configured to use AWS Managed Service for running machine learning models. Model selection specifies the ID of the Stable Diffusion model hosted on AWS Bedrock. This model, known for its ability to generate images from textual descriptions, is identified by stability.stablediffusion.xlv1. Image decoding function. This function is designed to handle the response received from the AI model after an image has been generated. It takes the response object as an input. Parsing JSON extracts and passes the JSON body from the response using JSON.loads. This step converts the JSON formatted string into a Python dictionary, making it easier to access the data. Extracting image data retrieves the artifacts from the parsed JSON, which contains the generated image information. It then decodes the first artifact's base65 encoded data into raw binary data using base64.b64 decode. Creating bytes IO object wraps the raw binary data in a bytes IO object, creating a file-like object in memory. This makes the image data compatible with Python's file handling mechanisms and Streamlit's image display function. Next is image generation function. This function accepts a text prompt and style as input to guide the AI in generating an image. It constructs a request payload containing these inputs along with predefined model parameters. Request payload formats the request as a JSON string with JSON.terms, including the text prompts, CFG underscore scale, which is to control the model's adherence to the prompt, and steps, which is to determine the image's detail level. Invocation. Sends the request to the AI model via the AWS Bedrock client, AWS underscore bedrock.invoke model, and waits for the generated image's response. Then processing the response. The response containing the encoded image is passed to decode underscore image underscore from underscore response to extract the image data, which is then returned as a bytes IO object. Now, let's look into the Streamlit web app configuration and styling. App configuration. This sets up the Streamlit app with a wide layout for better display of content and names the app Personalized Artwork Creator. This injects custom CSS into the Streamlit app to enhance its appearance. This includes setting a black background for the app and ensuring all text and interactive elements like buttons are displayed in white for contrast and readability. Streamlit app layout and interaction. Page title displays the main title of the web application at the top of the page. This column setup divides the app interface into two columns. The left column, prompt column, is dedicated to user inputs, and the right column, results underscore column, is reserved for displaying the generated image. Input section. In the left column, users are prompted to enter a scene description and choose an art style from a drop-down menu. A button labeled Generate Artwork triggers the image generation process section. The right column displays the generated image once the Generate Artwork button is clicked. A loading spinner provides visual feedback while the image is being generated, enhancing the user experience. With our script all set, it's time to run it and see our tool in action. To get our app up and running, we use the command streamlit run name of your Python file server.port 8080. And there you have it. The app is live. If you are using Cloudline like me, you can use the preview feature to see your app in action. So here we can describe a scene and choose an art style, after which your artwork would be generated. Let's try it out. I'm typing photo of a baby girl taken with a DSLR camera in the describe the scene and art style to realistic. Now the artwork gets generated in line with our expectations. Let's try with a different style, maybe fantasy. And now we would be seeing a different artwork in line with the art style. Now you can use this to apply your own use case and make advancements as needed. While this is a very basic use case, the intention was to touch base on the concepts and approaches with a simple and straightforward use case, so it is clear for beginners and people who are not well versed with these technologies. While this tutorial covered the basics, the real magic happens when you apply these concepts to your own unique projects. I would love to hear your thoughts on this tool and the amazing things you envision creating with it. Drop a comment below with your ideas, feedback, or any cool project plans you have in mind. Let's inspire each other and grow our creative community. And that's a wrap for today's journey into AI-powered creativity. I hope you found this session as exciting as I did. If you enjoyed diving into the world of AI art with me, show some love by hitting that like button, sharing this video with fellow tech enthusiasts, and subscribing to stay updated on all our future adventures. Your support fuels more content like this, so let's keep the momentum going. Until next time, keep experimenting, keep creating, and see where your imagination takes you. Thanks for being an awesome part of our community. Catch you in the next video.